So let's actually now pivot to a few other ideas that we'll implement in Python. In a moment, let me switch back over to VS Code here. And let me whip up, say, a recreation of our scores example from week 2, where we averaged like 3 scores together. And that was an opportunity in week 2 to play with arrays, to realize how constrained arrays are. They can't grow or shrink. You have to decide in advance. But let's see what's different here in Python. So let me do scores.py. And let me give myself an array in Python called scores. Sorry, let me give myself a variable in Python called scores. Set it equal to a list of 3 scores, which are the same ones we've used before, 72, 73, 33. In this context, meant to be scores, not ASCII values. And then let's just do the average of these. So average will be another variable. And it turns out I can do, well, how did I sum these before? I probably had a for loop to add 1. Then I knew how long there were. Turns out in Python, you can just say sum of scores divided by the length of scores. That's going to give me my average. So sum is a function that takes a list, in this case, as input, and it just does the sum for you with a for loop or whatever underneath the hood. Lang gives you the length of the list, how many things are in it, so I can dynamically figure that out. Now let me go ahead and print out, using print, the word average, and then in curly braces, the actual average, close quote. All right, so let's run this code, python of scores.py. And there's my average, in this case, 59.33333, and so forth, based on the math. Well, let's actually now change this a little bit and make it a little more interesting and actually get input from the user rather than hard coding this. Let me go back up here and use from CS50 import getInt, because I don't want to deal with all the exceptions and the loops. Like, I just want to use someone else's function here. Let me give myself an empty list called scores. And this is not something we were able to do in C, right? Because in C, if you tried to make an empty array, well, that's pretty stupid because you can't add things to it. It's a fixed size. So it wouldn't even let you do that. But I can just create an empty list in Python, because lists, unlike arrays, are really linked lists. They'll grow and shrink. But you and I are not dealing with all the pointers underneath the hood. Python's doing that for us. So now let's go ahead and get a whole bunch of scores from the user. How about 3 of them in total? So for I in range of 3, let's go ahead and grab a score from the user using getInt, asking them for score. And then let's go ahead and append to the scores list that particular score. So it turns out that a list, and I could read the Python documentation to confirm as much, lists have a function built into them. And functions built into objects are generally known as methods, if you've heard that term before. Same idea, but whereas a function kind of stands on its own, a method is a function built into an object, like a list here. That's going to achieve the same result. Strictly speaking, I don't need the variable. Just like in C, I could tighten this up and do something like this as well. But I don't know. I kind of like it this way. It's more clear, to me at least, that what I'm doing here, getting the score and then appending it to the list. Now the rest of the code can stay the same. Python of scores.py, score will be 72, 73, 33, and I get back the math. But now the program's a little more dynamic, which is nice. But there's other syntax I could use here, just so you've seen it. Python does have some neat syntactic tricks, whereby if you don't want to do scores.append, you can actually say scores plus equals this score. So you can actually concatenate lists together in Python too. Just as we used plus to join 2 strings together, you can use plus to join 2 lists together. The catch is you need to put the one score I'm adding here in a list of its own, which is kind of silly, but it's necessary so that this thing and this thing are both lists. To do this more verbosely, which most programmers wouldn't do, but just for clarity, this is the same thing as saying scores plus this score. So now maybe it's a little more clear that scores and bracket score, plural, sorry, singular, are both lists themselves, being concatenated or joined together. So 2 different ways. I'm not sure one is better than the other. This way is pretty common, but .append is also quite reasonable as well. All right. How about another example from week 2? This one was called uppercase. So let me do this in uppercase.py, though, this time. And let me import from CS50 getString again. And let me go ahead and say before will be my first variable. Let me get a string from the user, asking them for a before string. And then let me go ahead and say after, just to demonstrate some changes, uppercasing to this string. Let me change my line ending to be that using our new trick. And this is where things get cool in Python, relatively speaking. If I want to iterate over all of the characters in a string and print them out in uppercase, one way to do that would be this. For C in the before string, go ahead and print out C dot upper, but don't end the line yet because I want to keep these all on the same line until I'm all done. So what am I doing? Python of uppercase.py, let me type in hello in all lowercase. I've just uppercased the whole string. How? I first get string, calling it before. I then just print out some fluffy text that says after colon, and I get rid of the line ending just so I can kind of line these up. Notice I hit the space bar a couple times just so letters line up to be pretty. For C and before. This is new. This is powerful in in Python, whereby you don't have to do like int I equals 0 and I less than this. You could just say for C in the string in question, for C and before. And then here is just uppercasing that specific character and making sure we don't output a new line too soon. But this is actually more work than I need to do. Based on what we've seen thus far, like from our agreement example, can I tighten this up further? Can I collapse lines 5 and 6, maybe even 7 altogether? The goal of this program is just to uppercase the before string. How might I do this? Yeah, in back? Stir.upper, yeah. So I could do something like this. After gets before dot upper. So it's not stir literally dot upper. Stir just represents the string in question. So it would be before dot upper, but right idea otherwise. And so let me go ahead and just tweak my print statement a little bit. Let me just go ahead and print out the after variable here after creating it. So this line is the same. I'm getting a string called before. I'm creating another variable called after. And as you propose, I'm calling upper on the whole string, not one character at a time. Why? Because it's allowed. And again, in Python, there aren't technically characters individually. There's only strings anyway, so I might as well do them all at once. So if I rerun the code now, Python of uppercase.py, now I'll type in hello in all lowercase. And oh, so close. I think I can get rid of this override because I'm printing the whole thing out at once, not character by character. So now if I type in hello before, now I have an even tighter version of the program here. All right, any questions then on lists or on strings and what this kind of function upper represents with its docs? No? All right, so a couple other building blocks before we start. Oh, where was that? Then to the right. The right. Yes, thank you. Yes, do I have to create this variable upper? No, I don't. I could actually tighten this up. And if you really want to see something neat, inside of the curly braces, you don't have to just put the names of variables. You can put a small amount of logic, so long as it doesn't start to look stupid and kind of overwhelmingly complex, such that it's sort of bad design at that point. I can tighten this up like this and now run Python of uppercase.py, writing hello again. And that too worked. But I would be careful about this. You want to resist the temptation of having like a long line of code that's inside the curly braces, because it's just going to be harder to read. But absolutely, you could indeed do that too. All right, how about command line arguments, which was one thing we introduced in week 2 also, so that we could actually have the ability to take input from the user. So we could actually take input from the user at the command line so as to take literally command line arguments. These are a little different, but it follows the same paradigm. There's no main by default, and there's no def main int argc char, or we called it string argv by default. There's none of this. So if you want access to the argument vector, argv, you import it. And it turns out there's another module in Python, or library in Python, called sys. And you can import from the system this thing called argv. So same idea, different place. Now I'm going to go ahead and do this. Let's write a program that just requires that the user types in a word after the program's name or none at all. So if the length of argv equals 2, let's go ahead and print out, how about hello, comma, argv bracket 1, close quote. Else, if they don't type 2 words total at the prompt, let's just say the default, like we did weeks ago, hello world. So the only thing that's new here is we're importing argv from sys, and we're using this fancy f-string format, which kind of, to your point too, it's putting more complex logic in the curly braces, but that's OK. In this case, it's a list called argv, and we're getting bracket 1 from it. Let's do Python of argv.py, enter, hello world. What if I do argv.py David at the command line? Now I get hello David. So there's one curiosity here. Python is not included in argv. Whereas in C, dot/whatever was the first thing. The analog in Python is that the name of your Python program is the first thing. In bracket 0, which is why David is in bracket 1, the word Python does not appear in the argv list, just to be clear. But otherwise, the idea of these arguments is exactly the same as before. And in fact, what you can do, which is kind of cool, is because argv is a list, you can do things like this. For arg in argv, go ahead and print out each argument. So instead of using a for loop and I and all of this, if I do Python of argv enter, it just writes the program's name. If I do Python of argv foo, it puts argv.py and foo. If I do foo and bar, those words all print out. If I do foo bar baz, those print out too. And foo and bar or baz are like a mathematician's x and y and z for a computer scientist when you just need some placeholder words. So this is just nice. It reads a little more like English, and a for loop is just much more concise. Allows you to iterate very quickly when you want something like that. Suppose I only wanted the real words that the human typed after the program's name. Like suppose I want to ignore argv.py. I mean, I could do something hackish like this. If arg equals argv.py, I could just ignore, let's invert the logic. I could do this, for instance. So if the arg does not equal the program name, then go ahead and print out the word. So I get foo, bar, and baz only. Or, this is what's kind of neat about Python 2. Let me undo that. And let me just take a slice of the array of the list instead. So it turns out if argv is a list, I can actually say, you know what, go into that list, start at element 1 instead of 0, and then go all the way to the end. And we have not seen this syntax in C, but this is a way of slicing a list in Python. So now watch what happens. If I run Python of argv.py, foo, bar, baz, enter, I get only a subset of the list starting at position 1, going all the way to the end. And you can even do kind of the opposite. If for whatever reason you want to ignore the last element, you can say colon, we could say colon -1 and use a negative number, which we've not seen before, which slices off the end of the list as well. So there's some syntactic tricks that tend to be powerful in Python 2, even if at first glance you might not need them for typical things. All right, let's do one other example with exit, and then we'll start actually applying some algorithms to make things interesting. So in one last program here, let's do exit.py just to do one more mechanic before we introduce some algorithms. And let's do this. Let's import from sys import argv. Let's now do this. Let's make sure the user gives me one command line argument. So if the length of argv does not equal 2 in total, then let's go ahead and print out something like missing command line argument, just to explain what the problem is. And then let's do this. We can exit. But I'm going to use a better version of exit here. Let me import 2 functions from sys. Turns out the better way to do this is with sys.exit, because I can then exit specifically 2 with this exit code. Otherwise, down here, I'm going to go ahead and print out something like hello, comma, argv bracket 1, same as before, and then I'm going to exit with 0. So again, this was a subtle thing we introduced in week 2, where you could actually have your programs exit with some number where 0 signifies success and anything else signifies error. This is just the same idea in Python. So if I, for instance, just run the program like this, oops, I screwed up. I meant to say exit here and exit here. Let me do that again. If I run this like this, I'm missing a command line argument. So let me rerun it with like my name at the prompt. So I have exactly 2 command line arguments, the file name and my name, hello, comma, David. And if I do David Malan, it's not going to work either, because now argv does not equal 2. But the difference here is that we're exiting with 1 so that special programs can detect an error, or 0 in the event of success. And now there's one other way to do this too. Suppose that you're importing a lot of functions and you don't really want to make a mess of things and just have all of these function names available without it being clear where they came from. Let's just import all of sys. And let's just change our syntax, kind of like I proposed for CS50, where we just prepend to all of these library functions sys, just to be super explicit where they came from. And if there's another exit or argv value that we want to import from a library, this is one way to avoid collision. So if I do it one last time here, missing command line argument, but David still actually works. All right, only to demonstrate how we can implement that same idea. Let's now do something more powerful like a search algorithm like binary search. I'm going to go ahead and open up a file called numbers.py, and let's just do some searching, or linear search, rather, on a list of numbers. Let's go ahead and do this. How about import sys as before? Let me give myself a list of numbers like 4, 6, 8, 2, 7, 5, 0. So just a bunch of integers. And then let's do this. If you recall from week 3, we searched for the number 0 at the end of the lockers on stage. So let's just ask that question in Python. No need for a loop or anything like that. If 0 is in the numbers, go ahead and print out found. And then let's just exit successfully with 0. Else, if we get down here, let's just say print not found. And then we'll sys exit with 1. So this is where Python starts to get powerful again. Here's your list. Here is your loop that's doing all of the checking for you. Underneath the hood, Python's going to use linear search. You don't have to implement it yourself. No while loop, no for loop. You just ask a question. If 0 is in numbers, then do the following. So that's one feature we now get with Python and get to throw away a lot of that code. We can do it with strings too. Let me open a file called names.py instead and do something that was even more involved in C because we needed strcomp and the for loop and so forth. Let me import sys for this file. Let's give myself a bunch of names like we did in C. And those were Bill and Charlie and Fred and George and Ginny and 2 more, Percy. And lastly, Ron. And recall at the time we looked for Ron, and so we had to iterate through the whole thing, doing strcomp and I++ and all of that. Now just ask the question. If Ron is in names, then let's go ahead and, whoops, let me hide that. I hit the command too soon. Let me go ahead and say print found as before, sys exit 1 just to indicate success. And then down here, if we get to this point, we can say not found. And then we'll just sys exit 1 instead. So again, this just does linear search for us by default. Python of names.py, we found Ron, because indeed he's there and at the end of the list, but we don't need to deal with all of the mechanics of it. All right, let's take things one step further. In week 3, we also implemented the idea of a phone book that actually associated keys with values. But remember, the phone book in C was kind of a hack, right? Because we first had 2 arrays, one with names, one with numbers. Then we introduced structs, and so we gave you a person structure. And then we had an array of persons. You can do this in Python using objects and things called classes, but we can also just use a general purpose dictionary, because just like in pset5, you can associate keys with values using a hash table, using a trie. Well, similarly, can Python just do this for us? From CS50, let's import getString. And now let's give myself a dictionary of people. DICT, open paren, close paren, gives you a dictionary. Or you can simplify the syntax, actually. And a dictionary, again, is just keys and values, words and definitions. You can also just use curly braces instead. That gives me an empty dictionary. But if I know what I want to put in it by default, let's put Carter in there with a number of +1, 617, 495, 1000, just like last time. And put myself, David, with +1, 949, 468. 2750. And it came to my attention tragically after class that day that we had a bug in our little Easter egg. If today you would like to call me or text me at that number, we have fixed the code that underlies that little Easter egg. Spoiler ahead. All right, so this now gives me a variable called people that's associating keys with values. There is some new syntax here in Python, not just the curly braces, but the colons and the quotes on the left and the right. This is a way in Python of associating keys with values, words with definitions, anything with anything else. And it's going to be a super common paradigm, including in week 7, when we look at CSS and HTML and web programming. Keys and values are like this omnipresent idea in computer science and programming, because it's just a really useful way of associating one thing with another. So at this point in the story, we have a dictionary, a hash table, if you will, of people associating names with phone numbers, just like a real-world phone book. Let's write a program that gets a string from the user and asks them whose number they would like to look up. Then let's go ahead and say, if that name is in the people dictionary, go ahead and print out that person's number by going into the people dictionary and going to that specific name within there, using an F string for the whole thing. So this is similar in spirit to before. linear search and dictionary lookups will just happen automatically for you in Python by just asking the question, if name and people. And this line's just going to print out whoever is in the people dictionary at that name. So I'm using square brackets because here's the interesting thing in Python. Just like you can index into an array or a list in Python using numbers, 0, 1, 2, you can very conveniently index into a dictionary in Python using square brackets as well. And just to make clear what's going on here, let me go and create a temporary variable, person equals people bracket name. And then let's say number equals people bracket name. And let's just print out the number in question. In C and previously in Python, anything with square brackets like this would have been go to a location in a list or an array using a number. But that can actually be a string, like a word the human has typed. And this is what's amazing about dictionaries. It's not like a big line of a big linear thing. It's this table that you can look up in one column the name and get back in the other column the number. So let's go ahead and run Python of phonebook.py. Found, not that, oh wait, that's not what's supposed to happen at all. I think I'm in the wrong play. Phonebook.py. What's going on? Print found. I am confused. OK. Let's run this again. Python of phonebook.py. What the? OK, stand by. What the hell? What am I not understanding here? OK, Rongshin, Carter, do you see what I'm doing wrong? What the? Say again? Oh, what? Yeah. Found. OK, we're going to do this. One sec. Whoa. OK. All this is coming out of the video. Thanks. All right. I will try to figure out what was going wrong. The best I can tell, it was running the wrong program. I don't quite understand why, so we will diagnose this later. I just put the file into a temporary directory for now to run it. So let me go ahead and just run this, Python of phonebook.py. Type in, for instance, my name, and there's my corresponding number. I have no idea what was just happening, but I will get to the bottom of it and update you if we can put our finger on it. So this was just an example now of implementing a phone book. Let's now consider what we can do that's a little more powerful in these examples, like a phone book that actually keeps this information around. Thus far, these simple phone book examples throw the information away. But using CSV files, comma separated values, maybe we could actually keep around the names and numbers so that, like on your phone, you can actually keep your contacts around long term. So I'm going to go ahead now and do a slightly different example. And let me just hide this detail so it's not confusing. Whoops. I'm going to change my prompt temporarily. So let me go ahead now and refine this example as follows. I'm going to go into phonebook.py, and I'm going to import a whole library called CSV. And this is a powerful one because Python comes with a library that just handles CSV files for you. A CSV file is just a file with comma separated values. And in fact, to demonstrate this, let me check on one thing here just to make this a little more real. To demonstrate this, let's go ahead and do this. Let me import the CSV library. From CS50, let me import getString. Let me then open a file using the open function. Open a file called phonebook.csv in append format, in contrast with read format and write format. Write just blows it away. If it exists, append adds to the bottom of it. So I keep this phone book around, just like you might keep adding contacts to your phone. Now let me go ahead and get a couple values from the user. Let me say getString and ask the user for a name. Then let me get string again and ask the user for their number. And now let me go ahead and do this. And this is new, and this is Python specific, and you would only know this by following a tutorial or reading the documentation. Let me give myself a variable called writer and ask the CSV library for a writer to that file. Then let me go ahead and use that writer variable, use a function or a method inside of it called writeRow to write out a list containing that person's name and number. Notice the square brackets inside the parentheses because I'm just printing a list to that particular row in the file. And then I'm just going to close the file. So what is the effect of all of this? Well, let me go ahead and run this version of phonebook.py, and I'm prompted for a name. Let's do Carter's first, +1, 617, 495, 1000. And then let's go ahead and ls. Notice in my current directory, there's two files now, phonebook.py, which I wrote, and apparently phonebook.csv. CSV just stands for comma separated values, and it's like a very simple way of storing data in a spreadsheet, if you will, where the comma represents the separation between your columns. There's only two columns here, name and number. But because I'm writing to this file in append mode, let me run it one more time. Python of phonebook.py. And let me go ahead and do David and +1, 949, 468, 2750, enter. And notice what happened in the CSV file. It automatically updated because I'm now persisting this data to the file in question. So if I wanted to now read this file in, I could actually go ahead and do linear search on the data using a read function to actually read from the CSV. But for now, we'll just leave it a little simply as write. And let me make one refinement here. It turns out that if you're in the habit of opening a file, you don't have to even close it explicitly. You can instead do this. You can instead say, with the opening of a file called phonebook.csv in append mode, calling the thing file, go ahead and do all of these lines here. So the with keyword is a new thing in Python, and it's used in a few different ways. But one of the ways it's used is to tighten up code here. And I'm going to move my variables to the outside because they don't need to be inside of the with statement where the file is open. This just has the effect of ensuring that you, the programmer, don't screw up and accidentally don't close your file. In fact, you might recall from C, Valgrind might have complained at you if you had a file that you didn't close a file. You might have had a memory leak as a result. The with keyword takes care of all of that for you as well. How about do we want to do this? How about let's do one other thing. Let's do this. Let me go ahead and propose that on your phone or laptop here or online, go to this URL here, where you'll find a Google form. And just to show that these CSVs are actually kind of omnipresent. And if you've ever used a Google form or managed a student group or something where you've collected data via Google Forms, you can actually export all of that data via CSV files. So go ahead to this URL here. And those of you watching on demand later will find that the form's no longer working since we're only doing this live. But that will lead to a Google form that's going to let everyone input their answer to a question like, what house do you want to end up into? Sort of an approximation of the Sorting Hat in Harry Potter. And via this form, will we then have the ability to export, we'll see, a CSV file. So let's give you a moment to do that. In just a moment, I'll share my version of the screen, which is going to let me actually open the file, the form itself. And in just a moment, I'll switch over. OK, so this is now my version of the form here, where we have 200+ responses to a simple question of the form, what house do you belong in? Gryffindor, Hufflepuff, Ravenclaw, or Slytherin? If I go over to responses, I'll see all of the responses in the GUI form here. So graphical user interface. And we could flip through this, and it looks like, interestingly, 40% of Harvard students want to be in Gryffindor, 22% in Slytherin, and everyone else in between the others. But you might have noticed, if ever using a Google form, this Google Spreadsheets link. So I'm going to go ahead and click that, and that's going to automatically open, in this case, Google Spreadsheets. But you can see do the same thing with Office 365 as well. And now you see the raw data as a spreadsheet. But in Google Spreadsheets, if I go to File and then I go to Download, notice I can download this as an Excel file, a PDF, and also a CSV, comma separated values. So let me go ahead and do that. That gives me a file in my Downloads folder on my computer. I'm going to now go back to my code editor here. And what I'm going to go ahead and do is upload this file from my Downloads folder to VS Code so that we can actually see it within here. And now you can see this open file. And I'm going to shorten its name just so it's a little easier to read. I'm going to rename this using the mv command to just hogwarts.csv. And then we can see in the file that there's two columns, timestamp column house, where you have a whole bunch of timestamps when people filled out the form, someone very early in class, and then everyone else just a moment ago. And the second value after each comma is the name of the house. Well, let me go ahead here and implement a program in a file called hogwarts.py that processes this data. So in hogwarts.py, let's just write a program that now reads a CSV, in this case not a phone book, but everyone's sorting hat information. And I'm going to go ahead and import CSV. And suppose I want to answer a reasonable question, ignoring the fact that Google's GUI, or graphical user interface, can do this for me. I just want to count up who's going to be in which house. So let me give myself a dictionary called houses that's initially empty with curly braces. And let me pre-create a few keys. Let me say Griff indoor is going to be initialized to 0. Hufflepuff will be initialized to 0 as well. Ravenclaw will be initialized to 0. And finally, Slytherin will be initialized to 0. So here's another example of a dictionary or a hash table just being a very general purpose piece of data. You can have keys and values. The keys in this case are the houses. The values are initially 0, but I'm going to use this instead of like 4 separate variables to keep track of everyone's answer to this form. So I'm going to do this with opening hogwarts.csv in read mode, not append. I don't want to change it. I just want to read it. As file, as my variable name. Let's go ahead and create a reader this time that is using the reader function in the CSV library by opening that file. I'm going to go ahead and ignore the first line of the file, because recall that the first line is just timestamp and house. I want to get the real data. So this next function is just a little trick for ignoring the first line of the file. Then let's do this. For every other row in the reader, that is line by line, get the current person's house, which is in row bracket 1. This is what the CSV reader library is doing for us. It's handling all of the reading of this file. It figures out where the comma is. And for every row in the file, it hands you back a list of size 2. In bracket 0 is the timestamp. In bracket 1 is the house name. So in my code, I can say house equals row bracket 1. I don't care about the timestamp for this program. And then let's go into my dictionary called houses, plural, index into it at the house location by its name, and increment that 0 to 1. And now, at the end of this block of code, that has the effect of iterating over every line of the file, updating my dictionary in 4 different places based on whether someone typed Gryffindor or Slytherin or anything else. And notice that I'm using the name of the house to index into my dictionary to essentially go up to this little cheat sheet and change the 0 to a 1, the 1 to a 2, the 2 to a 3, instead of having like 4 separate variables, which would just be much more annoying to maintain. Down at the bottom, let's just print out the results. For each house in those houses, iterating over the keys therein by default in Python, let's go ahead and print out an f string that says the current house has the current count, and count will be the result of indexing into houses for that given house. And let me close my quote. So let's run this to summarize the data. Hogwarts.py. 140 of you answered Gryffindor, 54 Hufflepuff, 72 Ravenclaw, and 80 of you Slytherin. And that's just my now way of code. And this is, oh my God, so much easier than C to actually analyze data in this way. And one of the reasons that Python's so popular for data science and analytics more generally is that it's actually really easy to manipulate data and run analytics like this. And let me clean this up slightly. It's a little annoying that I just have to know and trust that the house name is in bracket 1 and timestamp is in bracket 0. Let's clean this up. There's something called a dictionary reader in the CSV library that I can use instead. Capital D, capital R. This means I can throw away this next thing, because what a dictionary reader does is it still returns to me every row from the file, one after the other. But it doesn't just give me a list of size 2 representing each row. It gives me a dictionary. And it uses as the keys in that dictionary timestamp and house for every row in the file, which is just to say it makes my code a little more readable, because instead of doing this little trickery, bracket 1, I can say quote unquote bracket house with a capital H because it's capitalized in the Google form itself. So the code now is just minorly different, but it's way more resilient, especially if I'm using Google Spreadsheets and I'm moving the columns around or doing something like that where the numbers might get messed up. Now I can run this on hogwarts.py again, and I get the same answers, but I now don't have to worry about where those individual columns are. All right. Any questions on those capabilities there? That's a teaser of sorts for what some of the manipulation we'll do in PSET 6. All right, so some final examples and flair to intrigue with what you can do with Python. I'm going to actually switch over to a terminal window on my own Mac so that I can actually use audio a little more effectively. So here's just a terminal window on Mac OS. I, before class, have pre-installed some additional Python libraries that won't really work in VS Code in the cloud because they require audio that the browser won't necessarily support. But I'm going to go ahead and write an example here that involves writing a speech-based program that actually does something with speech. And I'm going to go ahead and import a library that, again, I pre-installed called Python text-to-speech. And I'm going to go ahead and, per its documentation, give myself a speech engine by using that library's init function for initialize. I'm then going to use this engine's say function to do something fun like hello world. And then I'm going to go ahead and tell this engine to run and wait while it says those words. All right, I'm going to save this file. I'm not using VS Code at the moment. I'm using another popular program that we used in CS50 back in my day called Vim, which is a command line program that's just in this black and white window. Let me go ahead now and run Python of speech.py and
hello world.
All right, so it's a little computerized, but it is speech that has been synthesized from this example. Let's change it a little bit to be more interesting. Let's do something like this. Let's ask the user for their name, like what's your name, question mark. And then let's use a little f string and say not hello world, but hello to that person's name. Let me save my file, run Python of speech.py, enter. David.
Hello, David.
All right, so we pronounce my name OK. Might struggle with different names depending on the phonetics, but that one seemed to be OK. Let's do something else with Python using similarly just a few lines of code. Let me go into today's examples. And I'm going to go into a folder called detect. Whoops, a folder called faces.py. Sorry, faces. And in this folder that I've written in advance are a few files. Detect.py, recognize.py, and two photos, office.jpg and toby.jpg, if you're familiar with the show. Here, for instance, is the cast photo from the office here. So here's a photo as input. Suppose I want to do something very Facebook style where I want to analyze all of the faces or detect all of the faces in there. Well, let me go ahead and show you a program I wrote in advance. That's not terribly long. Much of it is actually comments, but let's see what I'm doing. I'm importing the Pillow library, again, to get access to images. I'm importing a library called Face Recognition, which I downloaded and installed in advance, but it does what it says. According to its documentation, you go into that library, and you call a function called loadImageFile to load something like office.jpg. And then you can use a line of code like this. Call a function called faceLocations, passing the image's input, and you get back a list of all of the faces in the image. And then down here, a for loop that iterates over all of those face locations. And inside of this loop, I just do a bit of trickery. I figure out the top, right, bottom, and left corners of those locations. And then using these lines of code here, I'm using that image library to just draw a box, essentially. And the code looks cryptic. Honestly, I would have to look this up to write it again. But per the documentation, this just draws a nice little box around the image. So let me go ahead and zoom out here and run this now on office.jpg. All right. It's analyzing, and you can see in the sidebar here, here's the original. And here is every face that my, 10 lines of Python code found within that file. What's a face? Presumably the library is looking for something, maybe without a mask, that has two eyes, a nose, and a mouth in some kind of arrangement, some kind of pattern. So it would seem pretty reliable, at least on these fairly easy to read faces here. But what if we want to look for someone specific, for instance, someone that's always getting picked on? Well, we could do something like this. Recognize.py, which is taking two files as input, that image and the image of one person in particular. And if you're trying to find Toby in a crowd, here I conflated the program. Sorry, this is the version that draws a box around the given face. Here we have Toby as identified. Why? Because that program, recognize.py, has a few more lines of code. But long story short, it additionally loads as input toby.jpg in order to recognize that specific face. And that specific face is a completely different photo, but it looks similar enough to the person that it all worked out OK. Let's do one other that's a little sensitive to microphones. Let me go into, how about my listen folder here, which is available online too. And let's just run Python of listen0.py. I'm going to type in like David. Oh, sorry. No, I'm going to hello world. Oh, no, that's the wrong version. OK, I look like an idiot. OK, hello. There we go. Hello to you, too. And if I say goodbye, I'm talking to my laptop like an idiot. OK. Now it's detecting what I'm saying here. So this first version of the program is just using some relatively simple if, elif, and it's just asking for input, forcing it to lowercase, and that was my mistake with the first example. And then I'm just checking, is hello in the user's words? Is how are you in the user's words? Didn't see that, but it's there. Is goodbye in the user's words? Now let's do a cooler version using a library, just by looking at the effect. Python of listen1.py. Hello world. Huh. Let's do version 2 of this that uses a speech-to-text library. Hello world. OK, so now it's artificial intelligence. Now let's do something a little more interesting, the third version of this program that actually analyzes the words that are said. Hello world. My name is David. How are you? OK, so that time it not only analyzed what I said, but it plucked my name out of it. Let's do 2 final examples. This one will generate a QR code. Let me go ahead and write a program called qr.py that very simply does this. Let me import a library called OS. Let me import a library called QR code. Let me grab an image here that's qrcode.make. And let me give you like the URL of like a lecture video on YouTube or something like that. With this ID, let me just type this so I don't get it wrong. OK, so if I now use this URL here of a video on YouTube, making sure I haven't made any typos, I'm now going to go ahead and do 2 lines of code in Python. I'm going to first save that as a file called qr.png, which is a 2-dimensional barcode, a QR code. And indeed, I'm going to use this format. And I'm going to use the os.system library to open qr.png automatically. And if you'd like to take out your phone at this point, you can see the result of my barcode that's just been dynamically generated. Hopefully from afar that will scan. And I think that's an appropriate line to end on. So that's it for CS50. We will see you next time.